Hello, my name is JJ Asgar, and you are probably checking in on, hopefully watching this video. If you're in the wrong place, I'm sorry. Otherwise, I am here to go on a little journey with you to learn some new stuff. So today, my plan is to play around with Elasticsearch. Thomas Kate, he is running a little bit late right now. He will join us when he can. Is going to be helping me spin up an Elasticsearch cluster on a 3-node cluster, and we're going to play around with it for a little bit. Then my plan is initially to destroy it and then build up another one using some technologies called Habitat from Chef Software and something called Open Policy Agent. So you can check for security policies for your Elasticsearch cluster. Hopefully this will take all 3 hours. I realize that it's Friday, and people probably have more important things to do instead of watching me stream or view this stuff, but that's fine. I am watching the chat in another window, so if you have any questions or thoughts, I'd love to hear from you. But while I'm waiting for Thomas to join us, I do actually need to set up some of the machines. If you look here, here's Elastic. It's elastic.co. And this is the actual main website. We're going to be doing our own version on a VMware cluster. And as you can see here, I have 3 machines. Hopefully this is not too small. I have 3 machines called ES1, ES2, and ES3. I basically cloned a very simple template here. It's called CentOS template, and created those machines. But as you can see, as I SSH into the 135 right here, the machine names are wrong. So if you don't know how to change your host name on CentOS, that's what I'm going to be doing first, and then rebooting the machine. So if you go to just, you log in as root, and then vi etc hostname, believe it or not, that's actually all it is. You go to there and then do ES01, then do reboot, and that's pretty much it. It's actually quite simple inside of CentOS to be able to do these things. Though I will say CentOS does have a lot of security built in by default. IP tables is enabled, handful of other things, and I have not messed with any of that. So we will probably be messing with that later when Thomas joins us. So if you see here, here's my template. And then I will do vi etc hostname, and see, it's once again, it's my template name. So ES02. There we go. And reboot. And then finally ES03. And that is 100. Yes. ESSWORD. And then vi etc host. This is ES03. Okay, so let's go back to our original machine here, which was ES01. So if we go up arrow, up arrow, up arrow, we should see. There we go. We are now on ES01, which will make, so when we start naming our machines and pulling the stuff off, it'll make life a little bit easier for all of us to be able to know what machine we're actually on. And as you saw, I just rebooted the machines. Luckily, CentOS boots extremely quickly on VMware, so it gets it up and going. If you don't know, the way that vCenter, this is the main control, command and control of a VMware cluster, vCenter knows about and can read information directly from the machine using something called OpenVM tools. As you can see, the DS name has changed here to ES01, and the IP address is now 135. And it tells us what ESXi host it's on. It's quite nice. If you've never played with VMware or you've used VMware Workstation, don't get me wrong, VMware Workstation is amazing, and it's great for local virtualization. It does cost some money, which is unfortunate, but that's kind of what happens. This, on the other hand, is gluing a bunch of machines together, which you can see up here, called ESX01 through 3, that are physical machines inside a data center, as you can see here, with 56 logical processors and a total memory count of 127 gigabytes with 8 terabytes of storage. So it's quite a large cluster of stuff, which is kind of cool. And VMware, it allows me to oversubscribe and just send all my stuff out, and I don't have to really worry about it. And how quickly these machines come up using VMware is extremely impressive. So if you take this, let's just go back to this Debian machine here, and I want to create a new VM from this template. Let's call it testing VM. Sure, doesn't matter. And I go ahead and create it. VMware is smart enough to say if I just want my cluster, I can tell it specifically what host I want, or go on the cluster and find the machine that has the least amount of resources. And I want to put in nothing crazy here, and I want to just power it on. It actually takes that template, which is a base OS of a machine, and just ships it off to one of the machines. As you see, here's the clone. It's already taken, it's taken less than 4 milliseconds to be queued, and it is start time at 2:06, and it is completed at 2:06, so it took 10 seconds to clone. And then, as you can see, it's already powered on, testing VM. It's already being booted, and it takes a second for VMware tools to check in, but as you can see here, in a second, don't make a liar out of me. You're making a liar out of me. Come on. Show me some love. Just thinking about it. It's a 4 gigabyte machine, so it's not huge. It has 2 CPUs, as you can see, and a 40 gigabyte hard drive. There we go. 104. So I can go over here and SSH into 104. Yes. There we go. Here's my Debian template. That is how quickly you're running VMware on. This is actually software from IBM with a bunch of ESXi hosts, and pushed how quickly I can get disposable machines up and running, be able to play around with it, and then when I'm done with it, it's very quickly shut down. Age now. I shut it down. We'll come over here. We refresh this here. As you can see, it is now shut down. And I can just delete this from the disk. Yep. Making sure you're sure you want to delete it, and now it's gone. So, pretty straightforward, pretty fun. It's actually quite, if you have the opportunity to play around with VMware, I know the APIs have been notoriously bad in the past, but VMware is truly making huge leaps and bounds to be better about it. If you have an opportunity to play with it, I strongly suggest spending some time doing it. You can always reach out to me directly, JJ Asgard, just like my Twitch channel, on Twitter or whatever, and I can kind of walk you through some things if you ever have questions. It took me a little while to get my head wrapped around it too, don't get me wrong, but as soon as you do, it really is extremely powerful. Okay, so now I have 3 machines called ES1 through 3, which is nice. We will be installing. Hey, Thomas, is that you?
Hey, yeah, it's me.
Hey, buddy. So we're already on streaming. You can see my screen?
I can.
All right. How about you go ahead and introduce yourself for me?
Hey, I'm Thomas Kate. I work with Chef in the customer success team, and I'm here to help JJ out with some Elasticsearch stuff.
Awesome. So I kind of put a little agenda together at the very beginning of this little stream, and I'll pass it by you to make sure you're cool with this.
Okay.
So being that, Thomas knows from the past, I spent a lot of time in the VMware ecosystem. So I spent a little time describing what vCenter was and spinning up some machines inside of vCenter. But my theory here is, and I know we've had a couple conversations offline, but I'll say it here now. I would really love to just spin up a really simple 3-node three node ES cluster, and actually just inject some data into it, and then just kind of show me the very basics of it. And then what we can do is we can nuke all three of them and build it using Habitat and Open Policy Agent. Is that possible?
Yeah, it's actually open distro, but yeah, let's do it completely vanilla with the RPMs first, which should be pretty much dead easy.
That's the beauty of this little stream is we start from the beginning, and then you can talk about Habitat and the advantages that it has, and then open distro, you said, not open policy, to open distro.
Yeah, I'll get into that once we get to that point.
Okay.
And explain what all of that is. But let's start with just the very basics of Elasticsearch then.
All right. So give me a second here. So I've spun up 3 machines called ES01. Oh, that's ES02. ES01 is 35. ESWORD. My password is literally password. My voice is my passport. No, nothing. Okay.
I got the reference. Don't get me wrong. I just letting that one go.
There you go. So yes, I just changed the name. This is a completely vanilla box with CentOS 7. So that's where we are right now.
Cool. So let's get Java on there, and OpenJDK is going to be fine.
So that would be yum install OpenJDK.
I think OpenJDK 11. We might have to do a little bit of yum searching to find it.
Those are probably oh geez. Okay, yum search.
Do yum search OpenJDK.
OpenJDK grep 11. Oh jeez. Okay.
Java 11-OpenJDK is what you want.
All right.
So Java-11-OpenJDK.
Java-11-OpenJDK. Like that?
Yep.
There we go. We have to install X for this? Really? Ugh.
You gotta install libx. That's not all of X server.
Oh, okay. All right. Let's say that'd be dumb.
The Java ecosystem is the Java ecosystem.
That is very true. Should I install this also on the other machines I have?
Yeah, let's throw this on all 3.
All right, give me a second. Make this nice and big. And this was, the next machine is 58. So I should say root at 172.16.0.58. Install Java 11 Open JDK. Do your job. Yes. All right. And then next.
Now, waiting on Java to install is probably going to be the longest single step of all of this, just because it's pretty decently sized.
So right here already, this feels like we should be using some automation for this. Being that you work for Chef, you want to talk about the advantages of using Chef for bootstrapping this machine?
Yeah, definitely. So the big thing about Chef is you can automate steps like this. Instead of logging into 3 machines and manually typing in yum install a package, they would just be checking into your Chef server, and you'd have a resource saying, make sure OpenJDK is installed, make sure it's up to date, and then they would just get automatically updated, or when they're bootstrapped, they'd automatically install it for you.
Awesome.
Given that we're trying to learn the details of Elasticsearch here, though, we're going to do it manually just so that you see all the ins and outs and all the dirty little corners.
Perfect. So it looks like we got Java installed.
All right. So let's install the Elasticsearch package, and I'm going to drop a link to the RPM in the chat here.
All right.
To save you a little bit of time. This is also specifically to the version I've been doing most of my testing in.
All right. I'll put this over off screen, so if you need to send me anything else, we don't flood the screen with stuff. So wget, no, RPM.
You could actually just do RPM-I. Yeah.
PM-I.
Lowercase I.
Lowercase I? Okay.
Yeah, lower.
All right. There we go. Do your job. Good. And we'll do this over here.
I do love how you try to motivate the computer.
I believe these machines are actually in San Jose, and I'm in Austin, Texas. So, that I have to be very, very loud. Okay, so it looks like it's done, but it didn't actually start it for us.
Yeah, it actually doesn't automatically start it. It gives you a chance to go configure things first.
Okay.
So before we start this up, let's go poke around at the config files and get an idea of the things we're going to want to tune. So how much memory do these boxes have?
4 gigs.
4 gigs. All right. So the general recommendation for Elasticsearch is you usually give it about half of the memory on the box.
Okay.
And there is an upper limit to that. They don't recommend giving more than about 29 gigs because at a certain point, Java will flip over to 64-bit counters. And apparently that has some pretty big performance issues. So on very large servers, you would max it out at about 29, 30 gigs or so of RAM.
Oh, interesting.
So let's go tweak that setting because the default's going to only be 1 gig, and we're going to want to do 2.
Okay.
Go into Etsy Elasticsearch.
All right.
Are you actually using VI?
Mm-hmm.
I thought you were the Emacs dude.
Oh, no, I do. I mean, I can use tramp mode. I just hadn't set it up, but fine. I'll bring it up. Hang on.
I'm just giving you a hard time. I'm a Vim guy myself. In there's the jvm.ops file. Is the one you want to look at.
Options?
Yeah, jvm.options.
All right.
And the setting is right there, XMS and XMX. And anybody who's done a lot of Java stuff has seen these settings before. Yeah, we just want 2 gigs for both of those.
All right. And we got to do this on all 3 of the machines, correct?
Correct.
All right. So let's grab this guy. Yeah. Do we need
That'll
to make
give Elasticsearch a couple, like another extra gig to work with.
Okay. Do we need to? Whoops. Is there any other settings we should be changing around, or is that pretty?
There's a different config file that we're going to want to mess with.
Okay. So
It has all of the actual day-to-day running bits of Elasticsearch in it.
All right. All right. There we go.
All right. So let's go over to the first one. In that Elasticsearch directory, there's a file called elasticsearch.yaml.
Of course, it's YAML.
All of the Elastic stack uses YAML for their settings pretty heavily.
Okay.
There are a bunch of comments and stuff in here we probably don't care much about. You can set a cluster name, which is useful if you're running multiple Elasticsearch clusters. And this, go ahead.
I was going to say, so this is the way to be, like, is it descriptive? So if I was running one and you were running another, we would have our own cluster and they wouldn't be able to talk to one another?
Yeah, exactly. It gives it a unique description of the cluster. So if you just do a curl against the cluster, it'll give you the name of the cluster. It also means if someone in one cluster accidentally puts the IP of another in their config, they don't accidentally join that cluster because they'll say, oh, the names don't match, don't join.
Ah, cool. So Tech on Fire just said that the 64 memory bit pointers are used up more available on the heap space of 40 gigs of heap. Gives less than 29 gigs of heap space. Gives less. Wow, that is very confusing. So if you, in the side of the chat, Tech on Fire said the 64-bit memory pointers also use up more of the available heap space. So 40 gigs of heap gives less than 29 gigs of heap space.
Okay, yeah.
So can you explain that a little bit more to me? Because that is very confusing.
So I'm going to drop a link, and you should probably also drop this in the channel.
All right.
It sounds like Tech on Fire knows more about Java memory pointers than I do, which I'll admit I don't know a huge amount.
Okay.
But essentially, once you hit past a certain threshold and it has to use the larger pointers, your performance tanks. It becomes a lot more inefficient. It starts using more memory usage, which is why Elastic tells you don't ever do that. In fact, if you're running a very large on very large servers, like 128 gigs of RAM, they would recommend you launch multiple copies of Elasticsearch with less than, whatever your max is. They actually give you a command a little bit further down to find out what the max heap size is for your box before you hit that threshold.
All right, let's see if I can find it. Is it this?
You were looking right at it. Scroll up. You were. Keep going up. You can verify that you're under by starting Elasticsearch with the JVM options. It's the last bullet point on that list right there.
This one right here?
All right, see that bullet point? It tells you an option you can start Elasticsearch with, which will log what the heap max is on your box. And they say 26 gigs is the totally safe number. But remember, this only comes into account if you're on a box that has more than about 60 gigs of RAM.
I accidentally hardware muted myself there. My bad. Okay, so yes. So when would we actually? So in general, do you run Elasticsearch on really, really large boxes, or do you have like a little cluster, or is it like dealer choice?
It's kind of dealer choice. If you're running in the cloud, it generally doesn't make sense to go for an extremely large machine.
Okay.
Like 64 gigs of RAM is about as big as I'll ever build one.
Okay.
Because you want to set Elasticsearch to about half the RAM. I usually just set it to like 26 gigs. I've got automation that does that.
Okay.
Because it's very easy in a tool like Chef or Habitat to say, how much RAM do I have? All right, divide that by 2. If the number is bigger than 26, put in 26. If it's smaller, use that number.
Okay. I guess that makes sense.
But yeah, if you're using like a 1 terabyte of RAM machine, you're going to end up with Elasticsearch using a tiny sliver of that, and the rest just kind of going unused. Your file caches will use it, so it's not completely useless, and that's why they recommend leaving about half free, so that the kernel can cache things for you, which will help speed up actions that are reading from disk. But yeah.
Okay.
Java memory is something you can dive very, very deeply in.
Yeah.
So for now, I'd say let's just set it to 2 gigs on these boxes, and we should be pretty good.
Okay. All right. That makes sense.
Let's give it a cluster name.
All right. Well, remember, these are going to be ephemeral, right? So we're going to be just throwing these things away, but we still should do a cluster name.
If you don't set one, it'll just name the cluster Elasticsearch, which is just fine.
Okay. All right.
Keep going down.
Keep going down.
You can give them a unique node name. I think they will default to hostname if you don't give them one.
Okay.
Path.data we can leave alone unless you have like a data mount, you want to put your data somewhere else.
Got it.
Same with logs. You can bootstrap memory lock is something you usually want to run in production.
Okay.
It has to do with how Elasticsearch allocates its heap.
Okay.
However, to do that, to set that, you need to tweak the systemd unit file to allow it. And for the testing we're doing right now, it's not worth it because we're not going to do anything that's going to be very memory performance oriented.
Got it.
All right, keep going down.
So you can give it.
So the network settings are interesting. You probably want to change network host to 0.0.0.0.
Okay.
By default, I think it'll only listen on localhost, and then they won't be able to talk to each other.
Okay.
You can change the ports that things talk to each other on, but I wouldn't mess with that.
Okay.
It's also possible to change the IP address that it advertises to other machines. If you have, say, multiple IP addresses and you want to make sure that people get back to you on a specific one.
Got it.
But we're not going to dig too deep into that. This next one, discovery zen ping unicast host, is important.
Okay.
And we're going to just want to put the IP address of all 3 machines in there.
Oh, really? Okay.
Yeah.
All right. So that is the local machine.
It's an IP address they can talk to each other on.
And should I put it itself also in there?
So you can leave itself out. However, it's a lot easier if you got to configure a bunch of machines just to put them all in there. It won't freak out if it sees itself in the list.
Got it. That's kind of where I was going with that.
Yeah, this way you can use the same config on all 3 machines easily.
Yeah. So would you suggest that we SCP this around when we're done?
Yeah, exactly.
Okay.
That way we don't have to write the config 3 times.
Yeah. Or use some automation.
Yeah. And that's what the second part will be, which would be using Habitat, is a more automated way of doing all of these things, as well as adding some security to the whole mix.
Got it. All right, there we go.
Now, they give you a little formula here for minimum master nodes.
Okay.
And this is something that makes a lot of sense if you've ever dealt with cap theorem a lot. And it's basically, are you familiar with the concept of split-brained, or should probably actually explain that just to the audience?
Actually, even better yet, how about you start with cap theorem, and then because even though I have done a little bit of research in this, the idea is that people should be able to watch this and get the very, very base understanding. So yeah, start with cap theorem and then split-brained.
So cap theorem is something that you'll see a lot in distributed databases. And the idea is consistency, availability, and partition tolerance. Consistency means if I ask the same question to multiple nodes at the same time, do they all give me the same answer? So a lot of times you'll hear eventually consistent databases, and that in the cap theorem sense of consistency means they're just not consistent. So like you do a write here and then you check for it on another box and you get a different answer. A consistent database, you get the same answer everywhere. The next is availability. If things go wrong, can you still access the database, right? That one's pretty straightforward. The last is partition tolerance. So if nodes suddenly can't talk to each other, does it keep running? And these 3 things are kind of like a balancing act.
Okay.
Because if you want something to be very consistent and very available, it can't be partition tolerant. Because if they can't talk to each other, they can't give the same answer. So they won't be consistent. Got it. Or if they can't talk to each other, do you shut it down? Then it's not available. Yeah. You kind of have to tune. Yeah. The other problem is if they can't talk to each other and you do a write to one and a different write to another, they have a different idea of what the state of the world is. This node thinks this user has $1,000. This node thinks this user has $0, and your load balancer can randomly hit either one. You can see how this could be a problem for your application.
Absolutely.
There was a Bitcoin site or cryptocurrency exchange that went down because they were using a distributed database and the replicas had fallen behind. And someone was able to basically just keep taking money out because it wasn't the actual message to deduct the amount hadn't gotten to the replica yet. So what you want to do to prevent split-brained situations is tell Elasticsearch, hey, if there's ever less than this many nodes in the cluster, just stop working. Okay. And you want to set that to more than half. So you never get a situation where you have 2 groups of nodes that are succeeding. Okay. So if you have 3 nodes, you set it to 2.
Set it to 2. Got it.
Yeah. So if one guy falls out of the cluster, the other 2 will keep running, but that guy will shut himself down. Got it. That's what that formula is. You divide in half and then add 1. What they leave out of there is it's also round up. So if you have like 9 nodes, you'd set it to 6. Got it. But yeah, the idea is just never allow a situation for for two groups of nodes to exist in your cluster that aren't talking to each other.
Yes.
Because then bad things will happen.
Okay.
I think that might be the last setting we need to set here, but we can do a quick look through the rest.
All right. Oh, that's it. We got gateway and various.
Yeah, there are a ton more settings that you could set.
Okay.
But that's what we're just going to set for now.
All right.
So let's do a start on the service.
And that is this guy?
Systemctl start Elasticsearch.
All right. Sudo system.
Oh, I guess they want you to do a daemon reload as well. I'm surprised the package didn't do that itself.
And then enable the service. And then start it.
Yep, let's start this guy up.
There we go. Nice and started now.
Now type, let's go look at the logs for Elasticsearch.
Okay.
If you go to var log Elasticsearch.
Var log Elasticsearch. Yep.
All right. Now, you notice it's called elasticsearch.log. Interesting thing is that's based on the cluster name.
Ah.
So if you change the cluster name, the log file changes name.
Got it. Got it.
So let's just tail that elasticsearch.log. That's usually the one you're going to be looking at.
Okay. That's a lot of information.
Yeah. If you look at that message, Elasticsearch likes to talk to you in Java stack traces. But if you look at that, it says not enough master nodes discovered during pinging.
Right there.
And I can get into the difference between master nodes and data nodes and the different types a little bit later.
Okay.
But for now, we'll just treat them all the same.
Got it.
But remember, we just said minimum masters is 2.
Yes. Ah.
And right now, there's only 1. So it's doing exactly what we told it to, which is not start.
Got it.
So you can just control C that,
right.
And now we just need to copy that config to another box.
Okay.
And start up the service on another one.
All right. So we were back in Etsy, Elasticsearch. So we needed to copy or secure copy the Elasticsearch.yaml.
Yep.
Uh-oh. I have lost my terminal. Give me a second here.
That's not good.
No, that's not good at all. What happened?
You go talk to someone who knows something about VMware.
I know, jeez. Okay, so there's that one right there, and yeah, that one just completely just dropped on me. What the hell? All right. Yes. We'll go back to. Give me 1 second. SSH. No. SSH. Root at. What was that IP again? It was 135. 16.135. P. Ah! Can't type. There we go. So then Etsy Elasticsearch, and then SCP Elasticsearch.yaml to 172 root at 172.16.0, and that is this machine 58. Colon 58 at Etsy Elasticsearch. Did I spell that right? I did.
Yeah, looks right.
Okay. Alright, almost. Nope, can't seem to type a password for the life of me. There we go.
It doesn't make it easier to type having a bunch of people watching you?
Yeah, no, it never does. Never helps with all the people involved in this.
Can you type free-m real quick? I noticed that was kind of laggy. I'm wondering if it's low on memory or something.
No, these should be just completely open, not doing anything. So
yeah, it looks fine.
Yeah.
Never mind.
All right, so let's go back.
Probably just my my video lagging.
Yeah, no worries. Well, I am streaming from my laptop, and you know, SSH or VPN'd into a data center. You know, I'm putting this machine through its paces. This actual machine.
Yeah, that makes sense. I should probably stop my video and Zoom then.
Oh yeah, I can't even see you. So. Alright. There we go. Alright. So then we do
We should
the...
probably set up SSH keys in the future.
Well, yeah, I mean, I actually have a... I have an Ansible playbook that does that all for me, but I never got around to pushing it out. Because, you know, I'm Red Hat now, right?
Yeah, no, it makes sense.
Yeah. Alright, so the commands were over here because I'm lazy.
So you just need to do a daemon reload and then a start. The enable just means it'll start when you reboot the VM, but I don't think these VMs are going to live that long.
Ah, okay. Alright. Well, I will do that then. And then... start. There we go.
Okay. We'll tail out that same log, var log Elasticsearch.
Var log Elasticsearch.
And then elasticsearch.log.
Oh, here we go. Looks like we're actually doing stuff. Oh, wait, nope. Not enough masters discovered during pinging. So we need 3, don't we?
No, see right there it says needed 2.
But don't we have them all as masters right now?
Yeah, so they should be seeing each other, but they don't.
Hmm.
So Control C that.
Control C that. Hang on 1 second. There we go.
Do you have curl installed on this box?
I should. Yes.
So let's curl the IP address of the first one.
Alright, curl of the first one. 135. Alright, 17, 16, 135. Port, what was it? 9,000?
9200 should give you.
No, we're up
Give
to...
you the API.
What?
Well, that's a network error right there.
Yeah, hold on. You can ping. Oh, IP tables, you bastard. Ugh. Okay, so we got to go to all 3 machines and turn off IP tables because IP tables is jacking all this up. No.
Or add like a blanket allow all. Do IP tables -save real quick. That'll just output the current rules.
Dash dash.
It's one word. Yeah. Yeah. Then save. There it is. So these are all of your rules.
Mm-hmm.
So do you see that -A input -J reject up there? It's the first one that I can see on the page.
Yep, right here.
Copy that and do IP tables.
Mm-hmm.
Paste that afterwards, but replace the A with a D.
With a
Capital
D?
D.
Like that?
Yep, for delete.
All right. Do I need to go to ES1 to do that too?
Run IP tables save again and make sure we actually got it, because it looks like you put it in a second time and then deleted it. Just want to make sure it's not in there anymore.
Oh yeah, you're right. I did. There you go. It's gone.
All right, so invalid state, it'll drop. All right, run that on the other 2.
All right.
And I'm hoping these boxes are not exposed to the internet because we're leaving them wide open.
Yeah, no, they're not. These are very, very... It takes a lot of hoops to get to these machines. It really does. Alright, that was yes, that one. And then the other one was, I've already forgotten again. And that was 135. Alright, so then if we come back over here and we do the curl. There we go. Now we're starting to see stuff.
Yep, and actually, if you look at your logs, they probably clustered up.
That sounds bad.
Okay, Voltroned up. Is
There you
that
go.
better?
There you go. Oh, there we go. That looks better. That looks much better.
Yeah, they're Voltroning up. All right. So real quick, we're going to run that curl again, but we're going to add a little bit of flavor on the end.
All right. So the curl is there.
Hit /
Mm-hmm.
and then underscore cluster
Okay.
/ health and then !, pretty.
Like that?
Exactly.
Ooh. Okay.
Yeah. So status is green. Timed out is false. You can see right there that there are only 2 nodes because we haven't set up all 3 of them yet. We got our cluster name. There are 3 different statuses you're going to see, which are red, yellow, and green.
Okay.
Red means there is data that it knows should be available but isn't. Sometimes you'll see that when it's starting up, or if the cluster's gotten in a bad state, like if some members dropped and it can't find an index that should be there.
Okay.
Yellow means that it doesn't have enough copies of the data. So every index has built in a setting that says, I want this many replicas of this index. And if there aren't enough nodes to do that, or they're full, it'll say, hey, I've got the primary copy of each one, but I don't have enough replicas. There's something not right with this cluster.
Got it.
And then green just means everything's perfectly fine.
Good.
So let's get the 3rd node going real quick.
All right. 1 second.
We just need to copy the config to it and start it up.
All right. Give me 2 seconds. All right. This is over here. So what I did was cut. Oh, no. 58. 58. Oh, excuse me. I can't type. Uh-oh. SSWORD. Gah. PASSWORD. There we go. Oh, damn it.
So no firewall. Root has SSH with a password, and the password is password.
Yep. Well, there's a bang in there too.
I'm loving this environment.
Isn't that great?
And I wanted to start this with a focus on security.
All right, here we go. That's what I was looking for. Let's see here. This was ES3 100. And then go back to 100.
It didn't copy.
Because yeah,
you weren't in the directory and you didn't have an absolute path.
My bad. Wow, this is just embarrassing now. Alright, so cd...
Most of my job is watching people type Linux commands all day.
Alright. Then go back to ES3. There we go. And then we can do, that was system cuddle,
daemon -reload.
reload.
It just tells it to reload any systemd files that have changed, and then systemctl start Elasticsearch.
There we go. So then we can look at the logs.
Yep.
Tail-f for log Elasticsearch.log.
The other thing you can do is hit the health endpoint on the other one and see it go up to 3.
Oh, cool. Yeah, we'll do that in just a second. So just to make sure that I see it here, it's started. And then this is...
Yep.
There we go. There's all the
That's,
IPs. Mhm.
yeah, and then it found one, and they basically elect a master between the three of them,
Okay.
and that one manages cluster state and stuff. So it knows things are good once it sees that there is one.
Got it. Got it. Okay.
All right, so we have a working Elasticsearch cluster. Like, no security or anything fun like that, but it does do the job.
Okay.
So let's actually put some data in here.
Yes.
And something that I thought might be a useful kind of sysadmin tool would be to put like an inventory of your servers in Elasticsearch.
Okay.
Now, as a former Chef employee, I know you're familiar with OHI. So I was going to basically take the output of OHI and put it into Elasticsearch.
Okay.
And then talk about what's happening with the data as it goes in. Do you have OHI installed on these boxes?
No, I do not have. Like I said, these are completely empty machines. So
that being a Ruby gem and CentOS having an ancient version of Ruby, the easiest way I found to get it is actually, and you're going to hate to hear this, Habitat.
Really? All right.
Yeah, because you can install modern Ruby with that, and it's less steps than getting rbenv going.
Okay. Let's give it a shot. And I'll take some notes.
Yeah, so this is the big ugly curl to bash that'll get Habitat installed.
All right. All right. So it is this guy. It pulls in this install.sh and then pushes it into sudo bash. Right?
Yep.
So we're gonna be good sysadmins here, and actually we're going not just run that.
Yeah, if you want to dig through the installer for Habitat.
All right, so it looks like it's been professionally done, right?
You can tell that by looking at a page of bash.
Exactly. It's not some like random bad stuff.
Yeah.
Sudo bash. There we go.
If this gets your environment hacked, you can just come yell at me. You know where I live.
You know I will. Whoa, that's it? Wow, that was extremely fast. Okay.
So I don't see the. Oh, I think my screen's just a little bit lag behind.
Okay.
And we can use this as kind of an extra package manager, basically.
Okay.
The first thing we're going to do is install Ruby. So hab pkg install, and then it's core/Ruby, and then space, and then -b for binlink, which is going to tell it to make our default Ruby in our shell be this.
Oh, cool.
So run that real quick.
Yes.
Yeah, these days we make everyone accept a product license to do stuff. This is a tool that's made by Chef. If you want to find more info on it, it's at habitat.sh.
I'll throw that into the little chat here. Habitat.sh. There we go. All right, that looks good. Oh,
yeah, you can see it's pulling in all the dependencies it's going to need.
Nice.
And now, if you do say ls-lah/bin Ruby,
or ruby-v, and see that it's the most modern, very, very modern version now.
Yeah, and the bin Ruby is a symlink into the Habitat path. So that gives you a modern Ruby, though I did find you needed a couple other things if you want to build OHI, like if you just want to gem install it. So we're going to run that install again for core GCC and core make.
And core GCC and core. Can I do it like this?
No, I don't think so. I think you have to do them one at a time, and you do need the -b after them.
That's an issue. I should be able to do multiple packages. Yeah.
Yeah. Really, the proper fix would be to make an OHI package that depends on all the others, and then we could just install OHI. But that just doesn't exist yet. So I thought about doing that, but I ran out of time this week. All right. And then do make real quick.
All right. Make -b. Oh. Something didn't like it.
So make was already installed, so it didn't overwrite /bin make, which should be fine. Yeah, because it was trying to make a symlink, and it's nice enough to not blow away existing ones, so it doesn't mess up your system packages.
Got it.
Try to do gem install ohai now.
It looks like it's working.
When it comes to rubygems, this is where I cross my fingers.
Where's my Nokogiri? Show me my Nokogiri.
I don't think ohai has Nokogiri in it, just everything else that Chef makes.
You know, I'll put that PR in to make sure Nokogiri gets in there.
You're
think?
a bad person, DJ. Oh, we probably should have done no doc.
That's fine.
Whatever.
All right, so we got it.
All right. So the one annoying thing is that gem does not get bin linked automatically in this setup. So I prepared a one-liner to do that.
Thank you, sir. All right. So what you're doing is you're echoing out the path of core Ruby, so we don't have to actually know what it is. To lib Ruby gems 2. So I have 255 right now. Is that going to be a problem right there?
So do an ls on that whole path that I'm echoing in there. Because I think the gem actually ends up in a slightly different path. So replace that echo with ls. And then append lib ruby gems and see what folders are there. Because yours might be in a slightly different path.
No, maybe not.
Yeah, because I did this, I test installed this earlier, and that's the path where the gem ended up being.
Oh, interesting. That is, I'm genuinely surprised at that.
When it comes to how Ruby Gems does its paths, I'm not the guy to talk to you. I'm just doing this to get the ohai tool.
Yeah.
And try running ohai real quick. Oh, chmod plus x that, yeah.
Whoops, sorry about that. That was my Topo Chico falling off my table. There we go.
So ohai basically inventories your system and spits out a JSON file. So the idea with this is we're going to make an inventory of the system, spit it out as JSON, and then put that into Elasticsearch so that we have a database of what servers we have that we can query in Elasticsearch.
Nice.
Now, a tool we're going to want to install is JQ.
Okay.
Which is a command line JSON parser.
Okay.
That actually requires EPEL to install, so we could actually just grab that out of Habitat as well.
Okay.
Hab package install core /JQ-static. And then -b on that, so it's been linked.
I missed the B.
You can run it again with the -b, it's fine.
Okay.
So, yeah.
Like that?
Yep.
Okay.
Yeah, see, it sees it's already installed, so it doesn't install it, but it adds the bin link for you.
Nice.
So what we're going to want to do, first off, to get that data in, is we're going to want to create an index.
Okay.
And I already have some JSON ready to create that. So let's paste that into a text file, and then I'm going to explain what all these settings are for everybody.
Index.json. That's not pretty.
Yeah, that.
Zoom.
Yeah, I think, yeah, Zoom ate it. I'll throw that into a gist for you real quick. unless you just like to manually fix.
Actually, you know what I'll do? This is a good opportunity for me to, oops, come over here and.
Oh, actually, I know an even easier way to fix that. If you cat the file and pipe it to JQ, it'll fix it for you.
Yeah, it's fine. Oh, I need to be going through here anyway. The root at 172.16.0. Which is this machine number again? I will never remember these things. I need to set up DNS. You want to set up DNS with me?
No, I don't want to do anything with DNS with you. DNS is one of those things that's like, oh, this will be easy. This will be great. And you get eaten by a crew.
That's true. That is so very true. All right. Index.json. There. No. Okay, there we go. So then I put this in here, and then I do this, and then it's done. There you go.
I knew you'd end up in Emacs at one point or another.
It just works. It just works.
So when you create an index in Elasticsearch, and an index is kind of the same concept as a database in other things.
Okay.
It's basically a collection of documents.
All right.
You can give it some settings up front as to how many of what should be in your cluster, different mappings. So the settings we're doing here are non-standard, just because I wanted to tweak some knobs, just so you see some knobs get tweaked.
Okay.
One of them is number of shards. So when a document comes in and it gets sent to an index, it immediately will decide to put it in a different shard. So if you have 3 shards, each document is going to end up in one of those 3 shards.
Okay.
So you end up with a third of your data in each one. And I'm not entirely sure what the mechanism it uses for that is. However, you basically end up with 3 groups of documents. So you can use this to spread across how many servers your documents end up across.
And this is for redundancy, right? Like is there any real, like, so
the first one's not for redundancy.
Okay.
So if you had 3 documents, one document would be in shard 1, one document would be in shard 2, and the other would be in shard 3.
Okay.
So it's really more for scalability.
Okay.
Because say if you have no replicas, which we'll get to in a second, and the server with doc 1 goes down, you don't have doc 1 anymore. So there's no redundancy from that. But it does mean your reads are split across wherever those 3 shards end up being.
But wouldn't that be, as you scale out farther, wouldn't that be more network traffic? Because now you've got to figure out where the hell that document is?
Yeah. So when the query comes in, the box that gets the query needs to go check all the shards for the index to figure out which document they have and send it back. Now, you also have replicas. And what a replica is for each shard you have, make this many copies.
Okay.
So if you have 1 replica, there would be 1 copy of each shard, and 1 primary. So you'd end up with 6 shards total.
And that would be distributed across the 3 machines we would have?
Yeah, so each machine would get 2 shards.
Okay.
It also will make sure the primary and the replica of a shard are not on the same box.
Okay. So you have you would have 66% coverage on that then.
Yeah, so if any box went down, you still have the replica.
Yeah.
And it can just promote the replica to primary and create a new replica.
Okay.
In this case, I did 2 replicas, just because people don't mess with this much, and it's actually an interesting thing you can tweak. So in this case, there would be 9 total shards. So for shard 1, there would be 2 replicas. Shard 2 would have 2 replicas, and shard 3 would have 2 replicas. So 3 primaries and 6 replicas.
Okay.
And an interesting thing about that is your reads go up quite a bit because it actually load balances the reads between the replicas.
Oh, interesting.
So yeah, so the one search might hit the primary, the second search will hit the first replica, third search will hit the third replica and back, right?
Mm-hmm.
So you can scale out your reads pretty much indefinitely by just adding replicas.
Hmm.
However, it doesn't help you much with writes. It actually hurts you with writes because a write doesn't complete until it's in every shard it needs to be in.
Okay.
And every document you insert is going to go into a primary shard and then both of that primary's replicas.
Hmm.
So the write's not going to complete until it happens on all three boxes.
Got it. So isn't that like what was it? Swift from OpenStack, right? You wouldn't actually get the official callback saying that it was successful until it wrote everywhere, right?
That's the case with Elasticsearch.
Okay.
Everything is done through an HTTP API, but you don't get that 200 OK until that document is in every shard it's supposed to be in.
And it hits, like when we connect to this and we actually send this data in, can we connect to any of our ES machines, or do we connect to only one master?
So you can connect to anyone. So master in Elasticsearch is not in any way similar to master in Postgres or master in MySQL,
Okay.
which is a mistake I've seen a lot of people make. So what a master in Elasticsearch is it's the machine that keeps track of what node shard should be on and what shard should exist. And that's all it really does. So there is a concept of these different roles they have that I kind of hinted at but moved on. One of the roles is just doing the API. So when the query comes in, the Elasticsearch server will either query the master or have already queried it and have a knowledge of which indices exist and which shards are where. So when the query comes in or the insert comes in, it can figure out, oh, like this doc should be inserted in shard 1 of this index. And then it'll say, okay, the shard 1 primary is over here, the shard 2 is over here, and it kind of routes the actual query to where it needs to go.
Okay.
So all of your searches and inserts can go to pretty much any node in your cluster. And it's common for very large clusters to have a handful of nodes that just do that don't store data, they don't elect themselves to be master. They just sit there behind a load balancer and take users' queries and ingests.
I think I'm following you. Good.
And in our case, all 3 nodes are doing all of the jobs. So anything we can do can go to any node, and it'll route it to where it needs to be.
Do they have suggested like hardware for you to start splitting these services up into other things, or is it just kind of like?
There's a fair amount of documentation out there, but a lot of it really breaks down to how much load do you have, and are you having issues with your current setup? I'm using Elasticsearch pretty extensively at Chef for Chef Automate, which is doing node inventory type stuff and holding compliant scan data. And we actually haven't ever bothered breaking out the different roles.
Oh, really?
Because we found for the amount of traffic we deal with, 3, maybe 5 nodes that are fairly beefy is completely fine. But if you're, say, a big data company with 100 terabytes of data that's being queried by people who are doing stock exchange stuff and they care about the time of their response, you're probably going to be tweaking all that stuff.
Got it. So yeah, let's just take a quick aside real quick, and so we've talked about putting data into Elasticsearch. We talk about documents putting into Elasticsearch. So what kind of data? Is it just any JSON data? Is it any key value store? Or talk to me about that for a second.
So it only takes JSON.
Okay.
So it's any data that you can express as JSON. Also, it's going to flatten it and use a library called Lucene under the hood to query it.
Okay.
Which, if you deal with any Java search stuff, you'll hear about Lucene a fair bit. but it really gives you an easy way to query and search through a large amount of JSON. Usually people use it for timestamps data.
So wait, I thought,
Yep.
what's the difference between that and something like InfluxDB?
So I'm not an expert on InfluxDB. From what I've seen, it's actually pretty similar
Okay.
and kind of fills the same niche.
Okay.
So does Splunk.
Okay.
So a lot of people will use this to put server logs in. In fact, there's a lot of tooling around that. Tool called Logstash is most commonly named. And what you'll usually do with that is you'll make an index each day, and then you'll have the logs from that day will go in that index. And that's actually a really good way to do it. Because if you ever need to clean up logs, you can just delete the entire index for a day. You don't have to do a query to find the logs older than blah to delete them. You just delete, each index older than you don't need anymore.
Oh, I guess that does make sense, doesn't it?
Yeah. So if you use like Logstash or MetricBeat or any of those system tools, you'll notice that they just create a new index every 24 hours.
Ah, nice.
And that just makes cleanup way easier.
Cool.
For our little system inventory tool, we're not going to do that just because I was just making a very simple toy deployment thing.
Cool. All right. So yes. So we've talked about the shards and the replicas here. What's this mapping?
So mappings are a way where you can give a hint to Elasticsearch what the data is going to look like when it comes in. Usually it does it dynamically, and most people just leave it dynamic. But sometimes you can give it a hint like, hey, this is a string, make sure it stays a string, or this is an integer.
Oh, so you can actually tell an actual field in the mapping. So if it's like, if we go back to this Ojai over here, and we're like, so we always know time zone here is going to be a string, and we can declare right here time zone will always be. Or no, we would have to do time zone, or can we just do time zone in this case?
You would just do time zone because it flattens it out.
Okay.
And it doesn't actually have a string type; it has a text type. But yeah, you could do that to give hints to specific fields.
So it would be like time zone would be equal to text.
It's actually nested a little bit more than that.
Oh. I was trying to be clever and show adding something like that to this.
Yeah, well, let's add something like that. Let me just get the. So first off, it's under a root key of mappings with an S if you want to add individual mappings.
All right, so then we would.
So we're going to add a comma after mapping. And add mappings. And then under that, there needs to be a key called properties.
Properties. Okay.
And then under that, you'll make a key called time zone.
And then this would be text.
Actually, it's there's another sub-level, but most people put this on one line. So open curly bracket.
Here?
Yeah. And then you want the word type. And then text. Because you can add other things to the time zone, like whether it gets indexed or not, whether it gets saved. You can actually do a bunch of different things with that field, but the only thing we're going to do is like make sure this field is text. So
next question. Obviously, as someone who's trying to learn this stuff, and I've played with some JavaScript and some JSON in the past, I have some tooling around this. Do you have suggestions or thoughts on how to be able to write this type of JSON for if you're just picking this up from the ground?
So if you have Elasticsearch installed, I would highly recommend installing Kibana.
Okay.
Kibana, which is a UI for messing with Elasticsearch.
Okay.
which we can get a lot deeper in on a different day. But that does give you a way to execute queries from within their UI that's a little cleaner than just writing out text in JSON.
Got it.
Other than that, honestly, day to day, I mostly use Vim and JQ to get the job done.
Okay. Okay.
I either use that for basic queries or I go straight to using Kibana to draw really pretty graphs.
So
I don't do a lot of stuff in the middle.
So could I run Kibana on a separate machine and connect to this ES cluster? Is that how I should do it?
You could also just install Kibana on any one of those 3 machines.
Okay.
I just didn't want to dive into that during this right now.
Sure. No, it's just a question.
Yeah. No. Kibana just talks to the API through port 9200, like everything else.
Okay.
So you can install it pretty much anywhere that can talk to your cluster. If you do SSL and auth on your cluster, Kibana can handle that as well.
Nice.
And then go make some pretty graphs. I've used it a fair bit in my past for. You can make a good ops dashboard with it.
Okay.
In fact, probably next time we get together, we could dig into doing like an ops dashboard with Kibana, where we take our server inventory and show pretty graphs on the servers.
Nice.
And like pie charts of how many Linux and Windows servers you have and things like that.
I mean, as you can see, I'm slowly but surely building more and more servers here. This right here, this OKD master and node, this is actually going to be an OKD OpenShift cluster. So I will actually need to have some real ops data here. So that sounds very exciting to me.
Yeah. So we could actually turn this into a real ops dashboard and we probably won't actually end up using this OHI data in the end. We'll just use some of the built-in elk tooling.
Okay.
This is more of like an interesting way to go through what it looks like to make an app that talks to Elasticsearch and puts data in it.
Sounds perfect.
So let's save that JSON.
I have.
And put it on a box that can hit that API endpoint. It could be on one of those servers or
it's there.
Cool. So we're going to want to create an index. And to do that, we're going to do a different HTTP verb.
Okay.
So you want to do curl -X put. It's no space between those two.
Oh, really?
Yeah, just XPUT.
I did not know that.
And that's going to send an HTTP put to Elasticsearch. And they're actually picky about content type headers on a few endpoints. So add that string I just sent you, which is content type application JSON.
Copy. Like that?
Yep. And then you want to put localhost 9200.
Oops. Off the screen. Hang on. Localhost 9200.
And then /. And then the path is actually going to be the name that we want to use for the index.
So OHI?
So, yeah, we could call it OHI.
All right.
And then space
Okay.
-D for data.
-D for capital D or lowercase?
Lowercase d.
Okay.
And then with no space after it, you want to put the @ symbol and then the name of your file.
And that is index.json. So like that.
Yeah, so basically curl is going to do a put on the URI, tell it it's going to be JSON. So Elasticsearch should read our JSON, create an index with those settings. So let's see if it does it.
All right, 1 second. Oops, I hit the wrong button. There we go. Oh, something happened. Unknown setting, time zone type.
So it didn't like how we did that mapping. Mappings. Looks correct to me.
Decimal properties wrong. Properties. Nope. Time zone.
Just checking that. Looked right. I'm double checking that against the examples in the docs. Oh, yeah. Sorry, I was looking at slightly too recent of docs. You need to add a key under mappings before properties.
All right.
On 6x4, you still have to tell it what kind of doc it is, and it's going to be !_doc.
So wait, a key of question.
Sorry, quotation mark _doc.
DOC.
Misspoke there. Yeah, and then yeah, just fix all your brackets after that.
No, hang on. It's this one. No, it's this one. There we go. And then this guy comes over here. This guy goes there. Okay, there we go.
You don't have an underscore in front of DOC.
Oh, like that?
Yeah, like that.
Okay.
When I was looking before, I was accidentally looking at the Elasticsearch 7 docs, and this is 6x4. So let's try that again.
Hang on. Nope, still doesn't like it.
No.
Uh-oh, did I lose you?
No, I'm still here.
Okay.
It does not like the setting that we just added on the fly there. Unknown setting, index mappings.
Is it because we haven't created the index yet?
No, you can specify mappings when creating an index.
Okay. That is interesting. Should I remove this doc, or as you said, this is the version that we're
yeah, just take that whole mappings section out, because we're telling it to put a thing that should be text as text, and we can mess with mappings at a different time.
Okay. Did I do that right? Did I screw this up?
You're missing a close bracket.
So yeah. Oops. There we go. There.
Yeah, the other thing I'm setting is the total fields limit, and that's because ohio puts a lot of fields in the JSON, and it's higher than the default that Elasticsearch will handle.
That looks like it worked.
Yep. So now let's actually, I threw a bunch of numbers at you when we were talking about shards that was probably pretty hard to follow.
Yep.
Let's actually look at what it did.
Okay.
So we're going to just do a curl on localhost 9200.
It's a curl on localhost 9200.
And then /_cat /shards.
Like that?
Yep.
Do I need to do that pretty thing again or no?
You don't, but actually do $B on this one. Yeah, run that.
All right.
All right, remember I said there would be 9 shards?
Mm-hmm.
So you can see there are 3 primary shards and 6 replica shards.
Mm-hmm.
And
so
you can see the IP addresses that it split them out amongst the cluster.
Mm-hmm.
So shard 1, the primary is on .58 and the replicas are on the other 2 servers.
Nice. Yeah.
Shard 2, the primary is on .100 and the replicas are on the others.
Mm-hmm.
And then shard 0, because of course it starts counting from 0, the primary is on 135. But if you look, the way we did our shards and replicas, every node has a complete copy of all of the data.
Yeah, that's really clever.
Now, that does mean if we have a lot of data with this kind of thing, we have 3 copies of every document. So we might want to tweak those settings so that there would be less copies of everything.
Okay.
But what that does mean, which is super interesting for our class right now, stop Elasticsearch on one of the nodes.
All right.
Not the one we're using to type commands on, just any other one.
Yeah, it's this one. So start, so stop. There we go.
And now do that curl against shards again.
There we go.
Okay, now we want to do, instead of cat shards, we want to do cluster health, and that one has the question mark pretty on it.
Oh, underscore cluster, right?
Yeah, underscore cluster. The top, since it uses that top level one for index names, if it's something internal, you have to give it the underscore to say, hey, this is an internal thing.
Got it. And then it's question mark pretty at the end?
Yep.
All right. Oh, there we go.
So you notice that the health is now yellow because it has 3 replica shards that it wants to put somewhere, but it can't because it won't put them on the same box as each other.
Got it.
And if you do cat shards, you'll notice something interesting. So remember I went through before and each IP address had 1 primary shard on it? Now 135 has 2 primary shards.
Oh, yeah. So it immediately was like, oh, God, it's gone. I need to put it somewhere.
It's gone. Yeah.
Yep.
These replicas are both up to date. And then the master picked a replica and said, you're a primary now. Congratulations.
And it's pretty much instantaneous, isn't it?
Yeah, it should be pretty quick. Now, if you start up Elasticsearch on that box again, it will sync all the data that node should have and bring it up to speed, which right now is nothing because we put no data in. It's Java. It takes a minute to start. I mean, I'm not hating on Java there. Like Tomcat takes about a minute to start. Like every Java app I've ever seen takes about a minute to start.
Hey, you want to hear a good Java joke?
Is this going to involve you pausing for a while and then saying something?
It's pretty funny, right?
Don't ever change, JJ.
Hey, you know you love me. You know you do.
Yeah.
There we go.
Yeah. So. So as soon as that one came up, it reassigned the shards. Interesting fact: it didn't move the primary around. So the one that just restarted has only replicas on it. It's not really a problem. It's just an interesting thing to be aware of.
Is there a way to force to make sure that the primaries and the replicas aren't all... Is there like anti-affinity rules that we could enforce?
There are different things you can do. The thing is, remember I said the writes don't commit until it's on the primary and all of the replicas. So they're all going to get the exact same amount of data at the same time. Okay. It just uses primaries and replicas as a way of like balancing things out.
Got it.
Also, in a real world cluster, you're regularly creating new indices at least every day, and as things go down and come back, you'll see things balanced different ways. If you look right now, docs is 0 and store is 230 bytes. As you'll end up with somewhat lopsided amounts of data if you have a bunch of different indices, because some indices are bigger than others, and it tries to balance them. So Elasticsearch will try to create, the master node will try to point shards at ones that have the least amount of data on them.
Okay.
So it does a lot of things internally to manage that state. So I've found it's generally a good idea to not try to muck with it. Just tell the index what kind of redundancy you want when you create it and let it handle the rest. Nice.
Trust the bots?
Yeah, you just got to trust the machine sometimes, which, it's going to go all Skynet on us, I'm sure. So let's get some data to put into this and start getting something kind of interesting. So we're going to want to run ohi and output to a JSON file.
Okay.
Now, I did find that there was one field ohi makes that just breaks stuff. So I sent you ohi with the JQ command that takes that field out.
Ah, okay. So hold on.
That field in ohi has like all the system limits on how big an integer can be and things like that. And those are bigger than Elasticsearch can handle, so it just chokes on it.
So if we run ohi through JQ right now, we will see a paginated. No, not paginated.
But prettified.
Yeah, made it all nice and pretty for us. What is it? West-F.
You actually have to do JQ space period if you pipe it to something.
Ah.
Which is...
No, I was trying to keep the colors.
less doesn't take the colors.
I thought it was that capital F.
Maybe.
Oh. I found it once, but anyway, the point being, I was going to try to show the colors. But so this is all our data that we're going to inject into it, and as Thomas was saying, JQ makes this all nice and pretty for us, so we can actually go through it. And the cool thing about his command that he gave is he said he actually goes and deletes that whole dot. So if we go, we can actually take it one step farther here, right? And we can just do that, right? And it should just give that sysconf, right?
Yeah. So this is the field I delete.
Yep.
And the one that was causing me heartburn in my testing earlier was a field that was like ulong something. There it is. See ulong max.
Ulong max.
Go down a couple pages. You could also pipe this to grep for ulong in all caps. It's right there. The problem is my display is about 2 seconds lag behind yours, so by the time I tell you it's there, it's too late.
Yes.
Ulong in caps.
As I'm staring at a bunch of capital letters, I'm like, I'm going to do it in lowercase. Anyway. Oh, wow. That is a rather large number.
Yeah. Elasticsearch sees that integer, and the parser just explodes. It's just like, no, I won't deal with that. I refuse to take this document. And looking at like that section, I was like, there's nothing particularly useful that I'd query on in here.
Mm-hmm.
Not that I can think of. Some of it you might find useful, but
yeah,
I just knocked out that whole section before trying to ingest it. And since you're going to have different ohi plugins, I would not be shocked to discover that there are fields that you're going to run into with problems that I didn't run into, which is a big lesson for anyone who's trying to ingest a bunch of fresh data into Elasticsearch. You are going to spend a lot of time thinking about what your data looks like and trying to fix it. Things really should be consistent. If you have something that's a string over here and you want to cat server JSON into JQ.
Yep.
Yeah.
I got there. So here's my VMware plugin doing its thing by default. That's really cool that Timmy rolled that up mainstream. Or
yeah.
I know I got still some love in the company. Let's see here. What else cool things have we found here? These are all the packages, right?
Yes, so you could do something like a query on a package and get back every node that has that package installed.
Mm-hmm. Mm-hmm.
You've got CPU info.
Mm-hmm.
You've got all kinds of good stuff. So let's take that document and push it into Elasticsearch.
All right.
So
that's another put command, right?
It's actually going to be post is what we're going to want.
Ah, okay. Post. Content type of JSON?
Yeah, you do need the content type JSON on this. I've actually got this in my bash history because we're getting to the edge of my notes. And then let me pull the screen real quick. Yeah, so the URL is going to be a little bit different.
Okay.
you're going to add on the end of it /_doc.
So /_doc.
Which is telling it I want to push a document in, and the JSON is going to be the document I want to put in.
Same data.
Yeah, -d and then the name of the JSON file.
Okay.
Let's give this a shot.
That looks like it. Yeah,
Yep.
successful.
So this is an interesting output to look at. So you see it's under a section called shards. And it says there were 3 shards it had to write to. So they're primary and 2 replicas, right? And that all 3 were successful.
Yep.
So if, for example, one node was down, and we can actually test this if you want, it should say 2 successful, 1 failed.
Yeah, because it can't write to one of them.
Exactly.
Yeah.
So you can see when you actually ingest a document, whether it got everywhere it needed to go.
So hold on, quick aside. So we have a JSON document that we're putting into it. So we would have to create JSON documents on the fly if we had like some API or something to push the stuff into it. Like you wouldn't create a JSON, like you wouldn't create this JSON server.json every single time you did it. How would you push data into it in a programmatic way?
So basically, what we're trying to make happen is a post of that JSON data to the API.
Okay.
So you could write a wrapper script that would run OHI, get the JSON, make any changes you wanted, and then post the JSON for you.
Okay. So you just glue some stuff together to kind of get that data and scrape it, and then push it into the database of Elasticsearch, and then you can start querying against it pretty much whenever that script is run. Yeah.
Yeah, because basically you're just trying to do a standard HTTP post against an API to get the data in. And on my GitHub, I have a couple examples of times where I've done this, and they're both Python scripts. I can dig up the links, and JJ can throw them in the chat later. One of them is talking to the Weather Underground API and getting the current weather stats from my area, converting that into the exact format I want, and then posting it into Elasticsearch.
Yeah, nice.
So I can just have a cron job run every like 5 minutes, and then I can make my own weather dashboard. The other one I have is taking network traffic data. It's actually called NetFlow data. And NetFlow is basically making a record of every IP connection that happens. And it has like source port, desk port, how many packets were sent, how many bytes were sent. So it has this datagram of all these stats for every connection. And I have that on my router just outputting these NetFlow items. And then I have something convert that to JSON and put it in Elasticsearch.
Nice.
And then I have something very similar to HTOP. I can be like, oh, this is how much traffic went to port 443. This is how much went to Google. This is how much went here, there, or the other. And then you can make graphs out of it.
Nice. So you can actually see where you can actually like audit your traffic to make sure it's going where you expect it to.
Exactly. Yeah.
Nice.
And I actually set up a friend of mine with it, and he's like, it's broken. It's showing way too much traffic going to China. And then he figured out the VM that he had that was running like XP that he used for pirating stuff had been hacked a long time ago and needed to be shut down.
That's amazing. That's amazing. So,
yeah.
Observability is important.
Yeah. So let's go look at that shards endpoint again, now that we actually have a document in there.
Oh, there we go.
Yep. Now the store goes up. It's based on Java memory stuff. So you'll see like adding a document will sometimes not make the size increase until it hits a certain point, and then it'll jump. So that's usually a meg or 2 high, depending on exactly how big your docs are. But it's usually not a problem if you have gigs of data, because that's pretty accurate.
Okay.
But sometimes with single documents, you'll see where it's a little inflated, because I don't think, do an ls-lah, how big of a document did we put in?
ls-lah, $79K.
Yeah. So it must have allocated a bit more storage to that just because there's a minimum for it to store some documents.
Okay.
But yeah, you can see it's in shard 0.
Mm-hmm. Mm-hmm.
So each node has a copy of that document now.
Nice.
And you can see the IP of each one.
Mm-hmm. Mm-hmm.
Let's go look at what that document actually looks like in Elasticsearch.
Okay.
So do a curl. Let's use the one that we already have before that has the content type and everything in it.
Mm-hmm.
Only instead of _doc, we're going to do _search, and we're not going to give it that JSON file.
A post also?
Let's change it to a get for this one.
Like that?
Yeah, run that.
Whoa! It pulled everything back for us.
Let's pipe that to JQ, and then maybe pipe it to less.
Yeah, it looks exactly the same.
Let's look at the very top, though. There's some interesting differences.
Okay.
So when it sends you a response, it gives back a few different details.
Mm-hmm.
So it took 62 milliseconds to go find the document.
Okay.
All 3 shards have it. And if you look, there's hits. It found one document, and then it gives you an array called hits that has every document it found.
Ah, nice.
You can also search over multiple indices at the same time. So if you have like a different index per day, you can search over an entire week by searching like 7 indexes.
What's this skipped mean? A skipped shard. Wouldn't that... Why would you skip a shard?
That I don't know, honestly.
Okay. No worries.
Yeah, definitely something I could do some reading on. There is an ID, so every doc gets a unique ID when it comes in.
Okay. Oh, that's this guy right here?
Yep. And then the actual document itself lives under _source.
Ah, okay.
So that's how, if you're making something that's searching, that you always end up going hits _source, and then there's the thing you actually want.
Ah, okay. So, in this case, it would be... Oh, really? Come on. Terminal broke again. So it would be hits _source oh god, I just saw it a second ago.
Oh, it's the second hits is an array.
I don't know.
So you want element 0 of the array.
No. Hits 0. Like that?
I think so.
And then
Like
there were
JQ foo. So that should give you just the document.
Yep. And then we can do VMware. There we go. Perfect. That's
So let's do a more efficient way to just get the VMware field. Because basically you pull down the entire document to just look at one tiny field, right?
Yeah, that is kind of dumb, isn't it?
So there's actually a way to tell Elasticsearch to only give you certain fields.
So I'm assuming it's under that search, just with another tagging something on it.
What you're going to want to do is actually feed it some JSON, because it actually takes all of its queries as JSON.
Oh, interesting.
So we're going to want to do a post. I'm quickly double checking docs. So let's make a JSON document.
Kids always read the docs.
Yeah. So open up your bracket, mustache bracket, and and then in quotations _source,
Mm-hmm.
and then colon, and then open an array. And in quotes, the first thing we're going to give it is VMware.
Okay.
And let's grab another field while we're at it. We're also going to grab hostname.
Okay.
Yep. And we're also going to specify the query we're doing. So before we just queried with nothing and it defaulted to match all.
Mm-hmm.
So let's be explicit about that. And like I said, we got past the edge of my notes, so you can hear me furiously Googling in the background. So put a comma there, and then the next field we're going to want.
Oh, sorry. Top field? Like this?
Yeah. The next top level field we want is going to be query with no underscore.
Okay. That's a weird inconsistency.
Yeah, well, it's because the field is named _source, because it's a special field.
Hmm.
They put that prepending underscore for a lot of their special stuff. Now the query actually is going to be a curly bracket.
Okay.
And the top level field under query is going to be match _all.
1 second. Hi. I couldn't pronounce your handle if my life depended on it. How am I doing? I saw your... Thank you. And... Oh, okay, cool. I appreciate that. Thank you for stopping by. This is just me learning how to play with Elasticsearch with Thomas Cade. Thanks so much. All right. So the query. There we go.
I guess that was someone taking it off. All right. So yeah, in quotes, you want to put match _all.
Match _all. All right.
So this is the simplest query because it basically just says just give me documents, and then colon, and then open and close bracket.
Oh, bracket like this one.
Yeah. No. Sorry, mustache bracket.
Mustache bracket. All right. Yep. I like that. All right.
Yeah. Because we're not giving any options to match all. We're just going to match everything.
Awesome.
Because there's only one document.
Makes sense. So we can go back to this guy with the dash
So
D.
you want to change it to a post.
Mm-hmm.
Yep.
And then, this should be search, right?
Mm-hmm.
And then this will be VMware.json. And then we should still push this into JQ just to colorize it.
Yeah, it's good to colorize your output.
There we go.
And if you scroll up, we got way less stuff back.
Absolutely. Absolutely.
And you can see you got the host name and you got the VMware.
And it feels like it was faster.
We'll scroll to the top. It told us the query time. It took 11 milliseconds that time, and it was like 62 last time.
Okay.
The problem with that is the document was also cached in memory because we'd read it before. So it's kind of hard to really come to good conclusions on just one get or one post.
Okay.
But yeah, it should have been faster because it was a lot less data it had to send back to your terminal.
Mm-hmm. Nice.
All right, so let's put some more data in there. And let's install Ohio on the other two servers.
Right.
And then we'll have some server objects in there that don't match each other exactly.
So we need to grab our install. So come with this guy and come back over here.
Yeah, if you already use something like Chef Client, Ohio is already installed, which makes that a little easier. It was just the first idea I came up with of generating random JSON that sysadmins might care about.
Works for me. Works for me. Let's just root that. That was S2. S2 16.0.58. And then I can come back over here or here and grab this one. Put that right there. Really helpful. Put the actual command in. And then we've got hab installed, and then we can go with hab package core Ruby. Yes. And then GCC. This guy is done with this one, so I can go back over here, take Ruby, put this over here. What is a sysadmin's life other than just watching something go scroll by a screen?
Mm-hmm.
There we go.
I'm putting together another like useful query that we can start doing once we got more data in there.
Awesome. Oh, I didn't do the gem. Gem install. Oh, hi.
Oh yeah, you actually have to install the gem and then make it a symlink.
Yep. It's Ruby, so this is now GCC. I gotta say, I am actually pretty impressed with how easy it is to get Ruby installed through Hab here and actually working. Like, no, like, I really am truly impressed. This is, it's been a long time since I've touched Hab, or Habitat for that matter.
It's gotten a lot better than where it was before.
Yeah. When I first started, there's a lot of sharp edges.
Yeah, we've been dogfooding it quite a bit.
All right, and then create this guy. So we're about to come up to 2 hours here on streaming.
Okay.
I honestly, I personally need a break. I've been sitting. I have old man legs, so I need to walk around for a minute. Let me.
You wanna take like 10 minutes?
Yeah, I think that's actually perfect. I'm planning on just doing this one last oh hi bit here. Type oh hi. Yep. Change mod plus 6. User bin oh hi. And go back here. That's working how I expect it to. And then change mod plus 6 oh hi. Yep. Bin oh hi. Oh. Type JJ. Come on now. So if I do oh hi here. There we go. Okay, cool. We got oh hi running through Hab on both of these machines. So yeah, let's take like 10 minutes. Just kind of
meet back up at 4 o'clock Central Time.
Yep. I'll go ahead and put the little "we'll be back" on the screen, and we'll see y'all in about 10 minutes. Thanks so much.
Yeah. See you guys in 10.
Gotta hit the right button, JJ. Come on now. Hello, and we're back. So, sorry, I was gone just a little bit longer than I was expecting to. This is what happens when you decide to check your email. After walking around for a second, you lose track of time. I'm joined here with Thomas Kate. Hey, Thomas, how you doing?
Hey, everybody.
So, we today have been playing with Elasticsearch. Just to be completely honest, I have used Elasticsearch in the past. I have consumed Elasticsearch in the past, but I've never actually understood the basis of it to build it back up from the ground up. And luckily, Thomas, a very good friend of mine, who we are playing board games this Sunday, correct?
Correct.
Good. He is, I'm just going to call it, very passionate about Elasticsearch. And he's walking me through some very basic kind of understanding of how everything's come together. We've already played with something called Habitat from Chef to allow us to install some Ruby on some really old CentOS machines. And we've spun up an Elasticsearch cluster. As you can see here on my screen, we have 3 machines, ES01, ES02, and ES03. We have just injected our first document into the Elasticsearch cluster, and now that we can run, just went brain dead. Now that we can run OHI on our other 2 machines, we're actually going to be getting that data in there. Is that about right, Thomas?
Yeah, we're using OHI here to just generate JSON documents that describe these servers, and then putting them into Elasticsearch. So we have kind of an inventory of our servers in Elasticsearch.
Perfect. Okay, so just before our little break, we were just running OHI on all our 3 machines. So we are now ready to start in putting more docs in.
Yeah, so let's, on the 2 machines that haven't ingested a doc yet, let's run OHI and output that to JQ to remove that one field.
This one right here?
And then output it to a file. Yeah, that one right there.
Oh, we don't have JQ.
So. Yeah, have package install core JQ-static will do that for you.
All right. There we go. And then this again. And then,
this time feeling.
Yep, exactly. There we go. And we're good.
All right, now if you do the curl on the shards endpoint, we should see 3 documents in there.
Well, no, we just only created the JSON. We have not actually pushed it in.
Oh, sorry. Yeah, we need to actually inject it. We got to do that post. Thank you. I jumped ahead.
Server JSON. So was this one? Yes, it was this one.
That's the one.
There we go. Pair programming is best, my friend. Pair programming is best. Okay, so we have successfully gotten both of these docs. So this, by the way, is this the only way we can get that doc ID is from this output, or can you query for this doc ID?
So actually, let's do that match all query again real quick. And then look at the output. I think the answer to your question is going to be right there.
What was it
We
called?
did a curl on there was a JSON that we did a curl using. It was a post. One of your JSON files should have match _ all in it.
Oops.
So look at your JSON files real quick.
Yeah. It was the VMware one. Yeah.
Yeah, so run that query again. And you actually inadvertently did something I was going to have you do intentionally next.
Oh, nice.
Further back.
Yeah, it's disappeared from my history for some reason.
Okay, so replace the get with a post.
Okay. Post. Mm-hmm.
And then add -d at VMware.json.
Oh, GQ, JQ. There we go. Ah, there it is. That's exactly what I was asking for.
Yeah, so the doc ID is in there. But you're going to notice something really interesting if you scroll to the top of this.
Mm-hmm.
How many docs are there?
There are 4?
Yeah, so right now when we insert the doc, we're not giving it an ID. So each time the doc comes in, it generates a new ID and puts the doc in there.
Oh, interesting. Interesting.
So when you accidentally reran that post that ingested the doc, there are now 2 copies of the doc for ESO1.
Oh. So can we delete one of those?
We can do a few different things, and actually, I'm going to talk about how we can prevent that from happening in the future.
Okay.
But first, let's do a little bit of querying on this since we have this data in here.
Okay.
So I'm going to show you the basic term query. So let's try to get out just the docs that reference hostname ESO1.
Sounds good.
So let's make a new query JSON file.
All right. So touch query JSON. We still need
And
pretty much
I'm
all
going to
that.
go through a couple different ways to do this.
All right. Okay.
So we might want to, let's keep the source filtering
Mm-hmm.
because we don't want to get the entire document for all of them, right?
That seems reasonable.
What fields do you think we might want to get back? Hostname is probably good.
Yep.
We probably want the IP address.
Seems reasonable. So I'm
Do you
assuming
know?
hostname.
So the field is just IP address, all is one word that OHI gives back.
Mhm.
So on hostname, put a comma after hostname and add IP address.
Like that?
Yeah. So for each document, it's going to give us the ID of the doc, give us the host name of the box, and the IP address of the box.
Okay.
And throw a platform on there too while we're at it.
All right. Okay.
And let's also do platform_version. We're gonna just spit out the typical stuff you'd want to know about a box that's in your inventory.
Okay.
And now for terms, under query, you're going to want to add a field called term.
Okay. Term.
TERM. Yep.
Okay.
And then you want to do the mustache bracket.
Mm-hmm.
And now most people keep this on one line.
Okay.
And then you're going to, in quotes, put host name.
Mm-hmm.
And then colon, and then in quotes, the host name of the box. And then you can close the bracket right there. That way, if you have a lot of terms, each one is on one line.
Got it. Oh, so we could actually have like that?
There are a couple different things we could do, and we'll mess with them in a second. But let's just do the simple one first with the single term.
All right.
There are also things like Boolean queries and things like that.
Nothing came out.
Okay. So, also on your curl, you want to add -s for silent. It makes troubleshooting a little harder if something goes wrong, but it takes out the downloading.
Mm-hmm. Mm-hmm.
So it like that. Run the match all query again.
Oh wait, hold on.
Or did you overwrite that one?
No, I didn't. It doesn't like the coloring here. You notice the coloring is different? It was wrong. The brackets aren't being matched properly. Or are they? I don't know.
It's probably just not happy. No, it looks right. I think it's just not happy that you didn't put that on the next line.
Oh, okay.
Because it didn't give you an error that it was invalid JSON. It gave you an error that it couldn't find a document.
Oh, doesn't comments not work in this one?
No, JSON does not accept comments.
I thought the // worked. There we go.
Nah. All right. And what was the host name you tried to use?
ESO1. ESO1.
So it should find it.
ESO1. Hostname. Term. Query.
All right, run it again.
Okay. Save. Wait. Did that work now? No.
No, because we're seeing.
ESO3.
All right, so real quick, show me the command you just ran. All right, cat out query.json.
Oh. Oh, I'm in the wrong window. Okay. What? Alright, so...
So did you use the same JSON file for the two different windows in your editor?
No, I copied and pasted stuff over to it. It's fine.
Weird.
Yeah, I know. So that's what we're looking for now, right?
Okay.
Yeah, nothing comes back.
Interesting.
What's going on here?
So, for some reason, that term is not sending back what we expect it to. I'm double checking the docs to see if there's an obvious we missed here.
No worries. Oh, excuse me.
So the term is an exact match. Can I see the output of the match all query earlier? ES-01. That looks like an exact match.
Is there a way to do an inexact match or whatever?
Try changing it from term to terms with an S.
Okay. Oh, and sorry, I just noticed that people have been talking in the channel. Hi, official Ochre. We are playing around with Elasticsearch from the ground up, which is kind of fun. And Tech on Fire, use match instead of term is a hostname a text field. We believe it is a text field.
Yeah.
And we are trying now terms. Let's see, cat terms, good.
Yeah, he might be right. We probably do need to use match.
Okay, yeah, terms is not supported.
Yes, replace terms with match. Thanks. Sorry, was it Tech on Fire?
Yep. Match. Can't use term with tech fields. Maybe I should have tech on fire on this call instead of you, my friend.
Maybe. Most of my experience is on the ops side of things. So go to the top of that, and you'll notice there's a field that's score.
Field that is score. Yep. No, total.
Like
Max score?
Scrolling through the documents. So it actually kicked back all 4 documents.
Mm-hmm.
Oh, Technofire is actually a guy I know.
Yeah.
He just pinged me on Slack.
Yep. You didn't know that? Yeah.
I did not know that. I now know his handle.
Yep.
Yeah, so if you look, it actually scored the documents and ranked them by score.
Ah.
So we can actually filter out documents or also use Booleans to say we definitely don't want documents that don't match. But often if you have a lot of different terms or a lot of different matches, you can do a search and just give the best possible answer back to the user and just say, hey, here's the best matching doc I could find for you. But it might be a little fuzzy match, right?
Okay. So like we could say anything with the score of over 70%, accept it and give just that one back. Is that what you're saying?
You could do that. Another thing you can do is just give them back the best one you could find.
Okay.
And the way you would do that is add another top level field on the query.
Okay.
And then that one is going to be a field named size.
Size. Okay.
And then you can just set it to 1. Yeah, you don't need the bracket there. Yep, just like that. This is not going to be inside a query. This is top level.
Oh, top level. Sorry.
Yep.
Like that?
Yeah, and run that real quick. So it's saying this is the doc we found that matches that the best.
Perfect.
You can also do top 5, top 10. This is useful if, say, you have a really large index of like Word documents or something, and they search for, okay, I want things by this guy, sent to this person, on this topic that contain this regex. It could give like, here are the top 5 best hits I could find for you, man. Even if like it wasn't necessarily like they have all of the things you searched for, it'll give you your best bet. So it's good if you're making like a search engine kind of thing.
So in that use case, could I, in theory, export out all my email from like Gmail and put it in my Elasticsearch cluster and be able to like de-Googleify myself?
In theory, you could, and then you make your own little search thing for your email.
Yeah.
Another thing you could do, if you just want to play with data, is all of the email data from the Enron scandal was released by the courts. It's all public information. So you could take something that could read all of those text files, convert it to JSON, put it in Elasticsearch, and do things like, what email, you can make even a graph of like, I want to see all emails from this guy, and then I want to see a top 10, how many times he emailed these guys. Who did he email the most? And go through and start making, connections based on the data.
Nice.
And graph out, like, even over time, like, oh, this guy started emailing this guy on this date and stuff like that. You could make some really interesting charts out of it.
Nice. That sounds really fun.
So let's look at one way to be more explicit on what we want.
Okay.
There are things like filters, but the thing I'm going to point you to next is Booleans.
Okay.
Because if you've done anything with computers, Booleans are lots of fun and come in handy all the time. So on our query over there, we're going to crank the size back up. So we'll just make it 10.
Okay.
And the key that's going to be top level under query is going to be bool, B-O-O-L.
So under query, so B-O-O-L.
Under query, yeah.
Yep. Okay.
And now bool has a few different options.
Mm-hmm.
And one of them is should. And should acts a lot like what we just did, where it's trying to boost things that have that. There's another that's must.
Okay.
So this is actually must is going to be, so under bool, you're going to have another bracket, and then must is going to be a field under that.
Oh, so like this? Ah. Like that?
Like that, yeah. And then another open bracket.
Must.
And then put your match right there. So your match goes directly under must.
Oh.
So you can actually just,
got it.
yeah, you already have your match on there.
Got it. I'm with you now. So like this.
Yeah, and then you could put multiple different, matches and terms and queries that all have to match, and say, give me all the documents that match all of these things.
Wow.
So try running this query now.
That's crazy powerful. The more like looking at it, the possibilities here.
Yeah.
Oh, nope.
Well, because you can also have another field under there. Something got messed up in our JSON, but you could have another field under there that is must not. So it's like, you could have like hostname must match this regex,
Mm-hmm.
but Linux version must not be CentOS 7. So then you have all the boxes in that field that are not CentOS 7.
Nice.
But that's complaining that we never closed the bracket for must.
There we go. And how quickly? How'd you find that so quickly?
So I've used most of these before, but here are the docs that have every query type. So I'm keeping those open to make sure I get the syntax right and things like that.
Yeah. Trying to bring the docs over. Again, kids, what do you?
Should probably at least link them in the in the Twitch chat so that people can bring them up and start going through them.
There we go. And what again, kids? Read the docs. Always read the docs.
The docs for Elasticsearch are pretty good, but a lot of times you find yourself in the deep end immediately. Which is why I was trying to cherry pick little bits and show things that are powerful without having to dig into everything.
So we're still pulling ES2 here, but the score is significantly lower now. So is that right?
Yeah. So that's the difference between a query context and a filter context. So a must is a lot stronger than should.
Mm-hmm.
Replace must with filter.
Filter. Good old band that I used to listen to when I was a kid.
Hey man, nice shot.
Nice.
Filter is still not doing it.
Well, no, it's the score is 0. So wasn't that what you're expecting?
It is still actually returning it to us, which I wasn't expecting it to even return the document.
Oh, actually, nothing. Everything is a score of 0. That is interesting.
Yeah, I was prepared to do a big security ops training class and fell into the deep end.
While you're looking that up, I'm actually going to look at something else up because my mind was just kind of wandering for a second. And if you've noticed that this platform version is 7.6, and that is actually how Ojai tells you what version of CentOS this is. And with Rel 8 out, why am I not running CentOS 8?
Is Rel 8 completely out? I thought the builds were. Well, Rel 8's out. I don't think CentOS 8's out.
Yeah, that's what I was just about to. I was just about to look that up because it feels like it should be. Let's see here. Minimal ISO. Yeah, no, I guess it's still Cent 7. Huh. Where's CentOS 8?
I was kind of surprised when you called this an old busted version of Cent, because I thought it was.
I really thought CentOS 8 was out. CentOS release date. Here we go.
Yeah, I thought it was imminently coming out, but I didn't think it had landed yet.
Build loops are going on. And aiming for July? No, I don't want to try Rel 8.
Wait, are you not a fan of Red Hat?
Hey, man.
Shouldn't you be pushing that?
Honestly, I've been a Debian user and a Ubuntu user for so long that when I look at a CentOS machine, it actually takes me a few minutes to figure out where things are. It really, really does take a little bit of time. I will say, if you go back over here, and you might have noticed, I am, and this may be a good stream for me one day, is I'm actually picking up Linux from scratch again.
Oh, God.
So that could be a little fun stream where I spend a couple hours going through Linux from scratch because, you know, I like to revisit my my what's a good word for it? Masochism, I guess. Okay. So, there we go. Tech on Fire, thank you so much. He went ahead and sent us this over here. And here we go. This is the actual status page. It is on the wiki. Oh, awesome. It is being built. Oh, it's exactly what we were looking for just a second ago. It's ongoing. The RC work is ongoing, and the release work has not started. Cool. That's good to know. Thanks for that. Oh, PPC 64. Oh, PPC 64.
That's still supported.
So it seems. Yeah.
Let's try something else on that query because I'm curious to see what's going to come back.
All right. Sorry about that. All right. Here we go.
We're going to keep the filter the way it is.
Okay.
But also add a must above it or below it at the same level as filter.
Oh, at the same level of filter.
Yeah.
All right, must. Yeah. Okay.
And then the must is just going to be a match all.
So match all. Okay.
It's actually must bracket and then match all and then 2 brackets.
Okay.
Mustache brackets.
Oh, mustache. Sorry. Like that.
So match all is a key, and then match all colon, and then just open and close bracket because we're not giving any.
Like that.
You need a comma right there. Yep. Try running that because match all will assign a score of 1 to all of the documents, and then the filter back that.
That did that. Added a score of 1 to everything. But didn't give us what we were looking for.
The filter match didn't do it.
I know one day I'm going to have to reinstall this laptop I'm on right now to Fedora. I know I'm going to. One day. But 1804 is doing good for me right now.
Oh, so match is fuzzy. So that's why they're all matching.
Okay. So... Wait. Even if we have an explicit string here, it still matches not? Really? This is kind of weird. No?
1 second.
No worries.
See what happens if you change match to term.
Match to term.
I thought you could do that on text fields as long as they were analyzed.
Nothing.
I guess not. It's not analyzed.
Yeah, so not exactly... I'm at a loss here. Tech on fire? Any
They do say to use match for text fields.
Hell, do you want to send in my Zoom link? Maybe he has an idea. He's in Seattle now, isn't he?
I have no idea where he's at these days.
Yeah, I think he moved from Alaska to Seattle.
Yeah. Let me find the Zoom link, and I will send it to him.
Awesome. There is like almost a maybe 20 or 30 second delay between the chat and what we're doing. Is that really you? Are you really there?
It's really him.
It could be me.
Hey, Will, how you doing, buddy?
Doing pretty good.
It's been too long, sir. It's been too long.
Looks like you guys are having some fun here.
Yeah, man. Mm-hmm. So, yeah, I figured, just invite you in instead of watch you scroll down slowly but surely after we've plugged on something because there's a little delay. But,
yeah.
You see what's going on here? Do you have any thoughts?
Yeah, this is a tricky one. Because part of the problem is that because it's a text field, when it gets analyzed, Elasticsearch actually modifies the value in the document it stores, which is why you can't use that term search for it unless you know how it's changing the values.
Okay. So dumb question. We're sitting here messing with this query.json, but if we had something like Kibana, couldn't we just put in hostname :ES01 instead of trying to do all this JSON, and it would give us just the ES01? How can
in Kibana, it automatically builds the queries on the back end for you. So if you're making a dashboard, it'll handle that.
Okay.
Yep.
But how do we emulate making those? Or are we trying to force right now that exact same thing? Does that make sense? Shouldn't this be something relatively straightforward? I'm honestly asking the question. It seems weird that we're having to deal with all this just trying to make a simple match against anything with ES1 inside of it. No?
I think we're just doing something slightly wrong, but I'm not sure what.
Okay. Well, I'm asking the question, right? So. Let's see.
We could also set a minimum score, but that does not seem like the best way to do it.
If we change the size to 1, so it only fits matches in 1, do we still...
That'll just give us the best hit.
Yeah. Yeah, it came back with
But if
4.
there were no ES, like if you search for ES04, when you search for that, you'll get something back.
Yeah, came back with the ESO1 actually.
Yeah.
Yeah, because it's
And actually,
internally what Elasticsearch is doing there is it's taking the value of hostname and when it analyzes it, it's actually splitting it into terms. So it's going to probably be splitting on the dash for that.
Mm.
Your query. So it's saying find me things that have ES and O1 in them, or ES and O4.
So if we just try O1 by that theory. Hey, we got 2 hits. Back to the in DM12 ESO1s.
oh, was it the dash that's throwing it off?
Yeah.
It's using it as a break, so it's splitting it. So you're essentially doing a search for find me things that have ES or O1 in the result.
Is there a way to like escape it like that?
Because of the fuzziness of the way match works.
Oh.
Think of match as sort of like a full text searching that you might do with like Postgres.
Okay. Interesting.
Kind.
Try ESO1 without the dash.
Alright. Nope. And there's no escape or anything like that, right? You can't do like slash ESO1 or something like that. Nope.
Yeah, I'm trying to think now. There's
2 slashes maybe?
So I think it's the tokenizer that's doing it.
So what? Yeah, here's what you can do. You can say ES space capital all capital and then O1.
Like that?
I think that's what you'd have to do to explicitly say.
Nope. Came back with 03. I'm gonna make this text a little bit bigger for people. Is that better? So back to that query DSL.
So the thing that's actually doing this is something called a tokenizer.
Okay.
I'm reading through this. And the standard tokenizer breaks it into words, and if it sees a space or a dash, it breaks it into different words.
Yep.
So exactly like Tech on Fire was saying, it's ES and O1. And I'm checking to see if we can change that field to use a different tokenizer. I think keyword is what we want.
Where's
Sorry?
Aaron?
Yeah, I think keyword is actually probably a better fit in this case.
Oh, for instead of match?
Instead of
Now,
Filter.
text.
Instead of what? I'm sorry?
so it's using the default one. Let me see how to put this in the query, because that is something that you see in Kibana a lot. Is you tell something, hey, this is a keyword. So let me see how we actually use a keyword.
Okay.
So it looks like it's actually a mapping type. So on the box real quick,
Mm-hmm.
do a curl on localhost 9200
Mm-hmm.
/ oh hi
Mm-hmm.
/ _ mappings.
Anything else?
Pipe that to JQ.
Ooh, that's a lot.
So pipe that to less and do a search for hostname.
Text.
Yep. Type text.
No, it's text.
Well, it's keyword.
Keyword is keyword.
So it's indexed in multiple ways. So it's text, but it's also a keyword.
What if instead of using just match, you use try match _ phrase?
Yeah.
Yeah.
That looks like it worked. We got our 2 hits for the 2 ESO1 docs. Now, what is the difference between match and match _ phrase?
So it's basically internally, it's going to it basically transforms that query into what's called a phrase query.
Mm-hmm.
Basically, it just is going to apply a different analyzer that is going to do the exact match against a thing that's been analyzed to do fuzzy matching.
And I imagine phrase is more like English-like, so then all of a sudden a dash is no longer a dash. It becomes something you would be matching against 2 different things. Is that right?
Yeah, so it's basically, so what'll happen is in this case, what's going to happen is it's going to do a query and it's going to say, find me a thing that has the phrase, that basically has the contents that has ES followed by O1.
Mm-hmm.
And that's the match. That's the only match I care. Those are the only matches I care about.
Ah, interesting. Okay, so we don't need this match all now, if I've got this right. So we just filter the Boolean on that. So this should still come back with 2, right? And it did.
Yeah.
And if you replace filter with must, they'll have a score. Right now they're coming back with a score of 0.
Oh, good call. There we go.
Interestingly, one of them has a higher score than the other, which I find kind of interesting.
That is weird, isn't it? It's the exact same data.
Yeah.
It's the exact same.
There are some different timestamps and stuff in there.
Oh, good point. No, well, no, because I just outputted it to the.
Oh yeah, you're right. There isn't. The only difference is when the doc was created and its ID.
Yeah. Yeah.
So let's fix the problem that we identified earlier, which is that each time you run this, you get a new document.
Yes. Yes.
So first off, we're going to clean out the documents that are in there.
Okay.
So we're going to do a delete by query.
Okay. So create a new query. Copy. Query.
Actually, we can use the match all query. So do you still have that match all?
Yeah, hang on. Match all.json. There we go. Let me make this a little bit bigger. Hang on. There we go. Sure.
And you can take that source filtering out of it,
Mm-hmm.
because we're not going to actually look at this one. And we're going to run this query against the OHI index, but we're not going to hit the search endpoint.
Okay.
So if you find that in your history real quick.
Oh.
See where we hit underscore search?
Mm-hmm.
So there's various endpoints under each index, and the one we're going to hit is underscore delete underscore by underscore query. This is basically drop star from star.
Got it. So like that. It's still a post?
Yep. Yeah, it's still a post.
Fail. Time. Deleted.
Did not time out. Deleted 4 documents.
Oh, perfect.
Yep. So now if you hit the shards endpoint, there's something interesting I want to show you real quick.
Mm-hmm.
It's still using the space from those deleted documents.
Oh, so it is. Yeah.
And there's a way to make it clean that up, but it should just reuse it as we put more documents in.
Okay.
Which is another reason it's a good idea generally to do timestamped indices and just blow away the whole index. Because sometimes if you delete some documents out of an index, you don't see the data come back.
Okay. I think I'm following you.
But yeah, there are no documents there. So go look at the command we ran earlier to create that document.
It was a put. This one?
It actually was a post. That was how we created the index. It was the post with server.json.
This one? The doc one?
Yeah, that's the one.
Mm-hmm.
So we hit the underscore doc endpoint on that index.
Mm-hmm.
Now, if you hit / after doc, you can actually put the ID you want this document to have.
Oh.
So you could just put like ESO1. And then / create after that. Oh, actually, you might not need that. So go look at how many docs are in there.
1.
And let's do that match all query. But we could do the VMware.json actually. Has it.
No. There we go.
Yeah. And now if you look, the ID is ESO1.
Oh, interesting. Interesting.
So run that again. The post to create the document.
Successful? Oh, updated. Updated.
Yeah.
Yeah.
So if you use something that you know is going to be unique, like a MAC address, or a hostname might not be, so MAC address might be a better choice. It's not going to create a new doc each time it checks in. It's just going to update the doc with the current stuff that's going on.
Nice.
Now, if you want to have historical data of how the node changed over time, maybe you do want a new doc each time, or maybe you just want one new doc per day. But yeah, if you specify the ID of the document when you put it in, you don't end up with multiple copies of everything.
Yeah, that's clever. That's real clever. That opens up some really nice ways of auditing your systems. It really does.
Yeah, that's why if you look at the Chef stuff, a lot of our stuff we generate our own UUIDs and use that as the doc ID instead of letting Elasticsearch decide, and that's why. So if a node checks in again, it keeps getting the same UUID.
Yeah, I had some problems with that in VMware, but that's a different conversation.
Yeah.
Cool.
Yeah, so now you can put some data in. You got some ideas on how things can go wrong. The query language is its own deep thing. Do you want to do one more thing before we finish up?
Sure.
Because I always like to tempt fate and anger Cthulhu.
Sounds good.
Let's real quick on the other two. Let's put a couple more documents in. So we'll just rerun the ingest. doesn't really matter what the doc IDs are.
Yeah, if I spelled it correctly.
No...
Yeah, I put the M.
Ah. All right, so now I'm going to show you a regex query.
Okay.
So go to one of the more complicated queries we did before.
Mm-hmm.
So in the source output, add kernel.version to the outputs that we want.
To kernel.version. Okay. I can't spell kernel correctly.
Yeah, that's E.
Mm-hmm.
And try just running that real quick and make sure we get back the field we expect.
Kernel version? Yep.
That's actually not the exact. Take off version and just get back all of kernel. Because that version doesn't actually give us anything very useful. Say we were searching for things that were an older kernel.
It's pulling in packages, it seems. No, it's not. These aren't packages. What the hell are these?
No, these are kernel
modules. Oh, yeah, you're right, modules. Working for release.
Yeah.
There we go. Right.
Oh, hi, it's not super consistent.
Where's Timmy when you need him?
I don't know who that is.
Tim Smith.
Oh, yeah, I do know that guy.
There you go.
So let's see if we can find any documents that are on a kernel newer than 3.10.
Okay.
So on the left,
Mm-hmm.
replace match phrase with regexp.
regexp. Okay.
And then hostname with kernel.release.
Release.
And then we'll do 3. Let's just do all the ones that are 2.star.
Okay. 2 star like that.
Yep.
Ooh, this is. Sorry.
I'm curious to see exactly what this does.
This is starting to feel really, really powerful. Nothing.
All right, change it to 3.star.
There it is. Nice.
Yeah,
Nice.
so that's something that actually could come in handy. Now, if you made your own OHI plugin that forced that kernel release to a number, like a float,
Mm-hmm.
then you could do comparators like greater than or less than.
Mm.
You could, but right now it's a text field, so that's not gonna quite fly.
Mm-hmm. Mm-hmm.
But you could definitely do you can also do must not. So give me every document where the kernel release is not 3.x. So must _ not works the exact opposite of must. So this will show you every box that is running a kernel release that's not 3.x.
Nice. Nice.
And you can do multiple different Boolean options to have, must not be 3.x or 4.x, and get back all your 2x's, all your 1x's, which I hope to God you don't have a 1x kernel in your field. But you can do this with platform version as well and find things that are lower than, say, 6.5.
Nice. Nice. That is extremely powerful.
Yeah, and you could even do a query that gives you, if you can find if you can treat platform version as a float, you could do a query that says, hey, sort them by lowest version.
Mm-hmm.
And then you could have a top 10 hit list on a dashboard that's like, these are the 10 lowest platform versions we got in the field.
Yeah. Okay. Go fix your shit.
Yeah. And then you can limit the query if you have timestamps on when your data comes in, because we could throw a timestamp on there. I don't think we did, though. you could say, hey, show the top 10, only query the last 24 hours. And then just put that on a dashboard in front of your ops guys and say, hey, here are the 10 oldest.
Yeah, that's amazing. That's really, really cool. All right, so
you just need the automation to get all your stuff sending the data in, and then you can start using it to get what you want out of your people.
Absolutely. So are you going to make that HAB plan to get Ojai working how we wanted to now? Is that what's going to happen?
Yeah,
next?
I didn't realize there wasn't one until I went and reached for it.
Yeah.
It would be pretty easy to make a habitat plan for that.
Yeah.
And then it would just be HAB package install Ojai.
Well, we could take a little break and you could walk me through it, and I can get some commit bits into Habitat. Just saying.
I don't think they're definitely trying to focus more over quality than quantity on core plans at the moment.
Okay.
It might not be something they'd accept into core plans, but you could put it in your own origin for sure.
Yeah, I think I still have my origins. Come to think of it.
Yeah, actually, so let me talk about what the open distro stuff was, because I briefly mentioned that and I never explained what it is.
We never got there.
It's actually going to be a fun little history lesson in Elasticsearch and open source stuff.
Okay.
So for the longest time, Elasticsearch did not open source any of their security related stuff.
Okay.
Which is basically SSL and authentication for Elasticsearch. And people basically were just forced to roll their own.
Mm-hmm.
AWS was not super happy about this because they do Elasticsearch as a service, and there was some funkiness as to what bits of the code were closed source and open source. So they made a hard fork of all of the authentication stuff and rebuilt it from scratch. And that's what Open Distro for Elasticsearch is. They also released it all under Apache 2.0.
Wow. Really?
However, they basically released the source, an RPM, and a Docker file.
Mm-hmm.
But if you wanted to deploy it on anything else, you were kind of on your own.
Mm-hmm.
So I built a habitat plan that builds all of the Java stuff and then compiles Elasticsearch. Actually, it doesn't compile it. It takes a tarball of a precompiled open source Elasticsearch and gives you working Elasticsearch with SSL and authentication out of the box without having to dig into all the tooling around Open Distro.
Wow. That's crazy.
I did that because we wanted a way to deploy Elasticsearch with authentication and SSL so that all the communication between the nodes is encrypted, communication to the nodes is encrypted, people have passwords, and then we end up not being part of giant data breaches, which is really our goal in life, is to not be involved in data breaches.
Exactly.
Now, soon after this, Elasticsearch did open source some of the authentication bits. So you can now do it with open source stuff, but you get all of the features if you go with Open Distro. So that's what I was originally going to have you do, and if we get together again, that's the path I'm going to take you down, which is using that to deploy Elasticsearch in a way that you'll have SSL on all the endpoints and authentication as well.
That is, yes, absolutely. That sounds like a great exercise, and also the correct way to set up your Elasticsearch cluster.
Yeah, well, because say you have a dashboard that has all of your servers checking in with all the versions of every package. And then you start doing security scans with inspec, and its output is JSON. So you put that in Elasticsearch too. And then somebody breaks into your network. They see that there's 9,200 open, no authentication, no SSL. They just start sniffing traffic and grabbing documents. That hit list of servers you need to upgrade and patch is now a hit list of servers for that guy to go find vulnerabilities on.
Oh, good point. Very good point.
Because that kernel query, you could easily make one that finds ones that have find servers that have known kernel vulnerabilities.
Mm-hmm.
So it would be a juicy target for anyone who got onto your networks. You might as well put some authentication on there.
Mm-hmm. Mm-hmm.
There also have been in the news a couple articles about massive data breaches related to companies putting large amounts of data in Elasticsearch and not locking it down.
Mm-hmm. Mm-hmm.
And then they say leave AWS firewall rule open, and then somebody in China just grabs all their data.
Mm. Yeah, that's not good.
Yep. So passwords, SSL, definitely worth going down that route. Another nice thing about using Habitat to manage all the servers is you can set up Habitat to be in a ring where every server is communicating with every other one.
Mm-hmm.
And then when you apply a config change to the ring, it updates the elasticsearch.yaml on all of them and then restarts the service automatically.
Mm.
So once you get that part set up, you're not having to like run a command on all 3 nodes. You just run it on any node that can talk to the ring.
Nice. So yeah, I want to do this. I really do.
Yeah, we don't have enough time today to even get started on that.
Yeah.
But that's what I was picturing for if we get together again, going down that route.
And because Open Distro, if I'm right here, it comes with Kibana already there. So
there's a separate Habitat plan for Kibana.
Okay.
But I also I'm one of the co-maintainers on that.
Mm-hmm.
So it's really pretty much as simple as pab package install Kibana.
Cool.
And then we can go into that side of things.
Yeah. So what are you doing on Tuesday?
On Tuesday, let me look at my calendar. Probably be easier to do this again on Friday because I do have a day job.
Okay. Yeah. Let's aim for next Friday then.
Yeah, because so if we can get that set up,
Mm-hmm.
the next place I'd like to kind of explore would be to make a real ops dashboard.
Mm-hmm.
We can have like all your VMware logs get pushed into it and the stats of your VMware hosts. Then you can get nice little CPU graphs and log searches and all that fun stuff.
Absolutely. Well, and as I said, then I can start adding it to my actual playground here. And what would be really cool is stupid VMware. I know, can't you inject Jenkins data into Elasticsearch also? Isn't there?
I mean, if you could turn it into JSON, you can.
I'm pretty sure you can, can't you?
Yeah, I'm not I don't use a whole lot of Jenkins in my life, so.
Yeah, unfortunately I do.
I would be surprised if there wasn't some kind of integration.
JSON output.
Yeah, I've actually hooked Sensu up to Elasticsearch in some interesting ways before.
Ooh.
At a previous gig I had. What we did is we had a system that was running postfix.
Mm-hmm.
So I was sending postfix logs into Elasticsearch.
Mm-hmm.
And then I had a query that would say, all right, look over the last 10 minutes. If there were more than 5 postfix failures in the last 10 minutes, send out an alert.
Mm.
And it was literally like a curl, and it was like, if this curl comes back with this field having more than this many values, go red, email me. So if something was wrong with our mail server, I would find out that way.
Nice. That is really cool.
And then Sensu was really just hitting that curl on Elasticsearch every 60 seconds or whatever. And there were a few other things like that where it was something that was aggregated across multiple mail servers or anything like that. I could easily do it by just checking Elasticsearch.
So it looks like this is exactly what I was hoping to find. This plugin takes the data and pushes it into Logstash endpoint? Is that a thing in Elasticsearch?
Yes. So you'll hear the phrase elk stack,
Yes.
and elk is Elasticsearch, Logstash, and Kibana. We've talked a little bit about the first and last of those. Logstash is a fascinating piece of old school style craziness.
Okay. All right.
It's the one. It's not Java. It's actually Ruby. It is a giant Ruby regex engine. And if you have, once you start getting into log parsing and you have arbitrary logs, there's a language called Grok, which Grok is really just a wrapper for regex. That you use to define how to turn a line of log into a JSON document. And Logstash can run as a server itself. So you have something sending all of your logs to Logstash, and then it chews on them, figures out what kind of logs they are, JSONs them, and sends that into Elasticsearch.
Oh, nice.
So you can use that to like turn your Apache logs into JSON documents. And then you can make like a histogram, like a line graph of Apache codes, per second of like 2x, 3x, 5x. So when your dev team does a release and suddenly the red line that says 500 suddenly spikes, to go yell at your dev team. And then you can do a log query on like, okay, do a regex query on the field status code for 5* or 5.* and like just start giving them example log messages that you're getting off your cluster of servers. And suddenly you're not like logging into servers and tailing a single log, and maybe you got the one that's broken, maybe not. You can just search on your little ops dashboard, and you never have to type on a command line at all.
That seems crazy powerful. Awesome.
It definitely is. It's why I'm a fan of this stuff.
Awesome. Well, I guess that's pretty much a great place for us to finish here.
Yeah, I think we're at a good stopping point.
Yeah. Will, you still there?
Yeah, I'm still here.
Well, thank you for joining us. And Thomas, thank you so much for walking me through this stuff. And
Sure.
I'm going to go ahead and end the stream. If you guys want to stick on the call for just a little bit longer, you're more than welcome to. But everyone who was watching, thank you so much. I'll be posting this to YouTube also. So if you find it through there, thank you for sticking with us the whole way through this. Hopefully you learned something. That is always my goal. I genuinely did learn quite a bit today. I got exposed to some stuff I hadn't had a chance to be exposed to. And I am starting to really truly see the power of Elasticsearch. Just like what I did earlier this week with Linkerd, today I have really understood the power of Elasticsearch, and I look forward to using more of it in my career. So thanks again, and I'll see you when I see you. Let's see.
Have a good one.
Where is the thing? There we go.